Question 2B. So from your past papers, please have that. August 2024, question 2B. That is the question we are starting with. Are you there? Now, are we looking at part B of that question? Now, before we look at part B, look at part A. Part A says, describe 3 types of money market instruments and their related transactions available in the financial system. That is from topic 2 that we covered. And we talked about the money market. Money market, remember we said is the market for short-term funds. Market for short-term funds. So there you find treasury bills, you find commercial papers, promissory notes, and the rest. They are there in the handout that I shared. So let's go to part B. I want, if possible, we do away with this topic today. So I want us to move a bit faster, yeah? So part B, Samuel Mongeka intends to invest shillings 200,000 at the beginning of each year in treasury bonds, which earns a return of 9% per annum. So Samuel Mongeka intends to invest shillings 200,000 at the beginning. At the beginning is very important. At the beginning of each year in treasury bonds, which earns a return of 9% per annum. Required, determine the accumulated value of investment after 10 years. So remember, this person, we're being told that this person will be investing 200,000 at the beginning of each year for a period of 10 years at an interest rate of 9%. So the 200,000 is an annuity. 200,000 shillings is an annuity in this case. So you say annuity. So this is part 1. So annuity is 200,000 because this is happening each year. So it becomes an annuity. Then the interest rate is 9%. 9% per annum. 9% per annum. The required, that is investment after 10 years. The number of periods is 10 years. So he's going to invest for a period of 10 years. This is an annuity due because it is occurring at the beginning. So present value of annuity due, we said is equals to the annuity times. So here we can choose to use we can use the tables or we can use the formula, whichever you want. So let's use the formula.
Given the following assumptions. So we are given a number of assumptions here. Number 1, we are given assumptions basically for preparing the statement of profit or loss. Number 1, you're told the revenue and the purchases are expected to grow at the rate of 10% per annum. Gross profit is 30% of the revenue. This will make it easier to determine the closing inventory. Administrative expenses grow at the rate of 5% per annum. Selling and distribution will likely grow at the rate of 10% per annum in line with revenue. Depreciation and amortization is on average 10% of the previous period non-current assets. Interest expense is 10% of end of last period balance of the long-term loan. Income tax expense is 30% of the profit before tax, and dividend is 40% of the profit after tax. So these are basic assumptions for preparing the statement of profit or loss. Then we are given assumptions for preparing the statement of financial position. Number 1, you're told the non-current assets are expected to grow at the rate of 5% annually, 5% annually, 5% annually, 5% annually. 5% annually. Then from there, we are told inventory is determined from the profit or loss. Number 3, we are told trade receivables will be 2 months of the credit sales, 2 months of the credit sales. Now, what do you mean by this? This is something I think you came across in FM, financial management, that trade receivables will be 2 months of credit sales. Who can be able to tell us the meaning of this, even before you move to the other assumption? Yes, what do you mean by this? That trade receivables will be 2 months of credit sales. What do you mean by this? What do you mean by this? Yes, what do you mean by this? Any idea? Any idea? Yes, any try, please try the meaning to give me the meaning of this. Yes, any idea? Yes, can you be thinking of that as we go through the other assumptions? But basically, it's something you came across in what? You came across in financial management, in financial management. Yes, and then you're told the cash at bank are expected to grow at 50% per annum. The share capital, I've said you keep on thinking about this one. Okay, I think we have a trial here. So trade receivables are expected to be equal to the value of 2 months credit sales. 2 months of credit sales. Okay, that is the answer I'm getting from Esther. Yes, so I also need to get trials from the list. What basically we mean by that. So and then we are told that the share capital and the share premium will remain constant over the period. And then you are told the long-term bank loan will be the balancing figure in the statement of financial position, just like the other question which we did yesterday. We are told trade payables are 2 months of purchases. The same with point number 3. The same with point number 3. The same with point number 3. And I'm saying that this is basically something you came across in financial management. I think in that topic of management of working capital. Management of working capital. So can you think of that? And then your total tax payable is 60% of the tax expense. And then the share prices are expected to grow at the rate of 5% per annum. So what are we required to do here? We're required to prepare the forecasted statement of a profit or loss from 2015 to 2029, and also the forecasted statement of a financial position equally from 2025 to 2020, 2025 basically to 2029. So we are basically going to start by preparing the statement of profit or loss. And basically we said that we need to have our solution here. So basically we will split our Excel worksheet, I think at that point, yes. So we can shade that. 120, 58, 0.68.
So it's what? Sorry. So this is here. It's 3 million. Okay, fine. So that must be the correct answer. That must be the correct answer. So the keynote here, it's the beginning. Remember the question says at the beginning of each period. And that is why we are having this factor here, 1 plus R. So take note of that. Then next part B, not part B, but part 2. Determine the present value of shillings 1.2 million annuity payable for 20 years at an interest rate of 8% per annum. So here, they're saying, determine the present value of shillings 1.2 million annuity payable for 20 years at an interest rate of 8% per annum. So again, this is still an annuity. And this annuity, they're saying, it is 1.2 million that is payable annually for a period of 20 years. So here we will say the annuity is 1.2 million. 1.2 million payable for 20 years. The period is 20 years at an interest rate of 8% per annum. Interest rate is 8% per annum. And we're looking at the present, determine the present value of shillings 1.2 million annuity payable for 20 years at an interest rate of 8% per. So they have not said whether the amount is at the beginning or as at the end of the period. So when the question does not specify when the payment is being done, it is assumed to be an ordinary annuity. So this is an ordinary annuity where the payment is occurring at the end of each period. So present value of annuity, which is an ordinary, we said is equals to the annuity times 1 minus 1 plus R power negative N over R over R over R. So this is 1.2 million times into brackets 1 minus 1 plus 0.08 power negative 20 over 0.08. So get that. Get the present value. Get me the present value kindly. I'm waiting for the answer. Hilda? Eleven 781 720. Eleven 781 776. Point 89. Let's say 89. So that is okay. That is how we get the present value of an annuity. So you can see, these are the same things that we were looking at during our classwork. What you need to do is to get the concept. You need to understand what you are computing, what information has been provided. Have I been provided with an annuity? Have I been provided with a lump sum? And things like that. Let's have another question, a quick one. December 2023. December 2023. December 2023. Question 3C. December 2023, question 3C. So December 2023, question 3C. Are you there? Yeah, question 3C say, no. This is on loan amortization, yeah? This is on loan amortization. December 2023, question 3C and D. Let's do part D. Let's do D, not C, D. We are coming back to part C on loan amortization. So let's have it somewhere. Question 3C. It's on loan amortization. So let's look at part D. Says, 𝐎𝐍𝐋𝐿 has the following investment options to choose from. 𝐎𝐍𝐋𝐿 has the following investment options to choose from. Post office MIS scheme, monthly interest 8% per annum. ICD bank deposit, quarterly interest 8.25% per annum. HDFC Limited have yearly interest 8.5% per annum. Required, using effective interest rate method, advise 𝐎𝐍𝐋𝐿 on the preferred investment option using the effective interest rate. So remember, we said effective interest rate. Effective interest rate, it is adjusting the nominal interest rate with the number of times compounding occurs in a year, so as to get an interest rate that is consistent with the number of compounding times. So effective interest rate, we said effective interest rate, we said is equals to 1 plus, this was R over M power M minus 1. That is what we said. That is how we compute the effective interest rate. That is how we compute the effective interest rate, unless I'm getting the formula wrong, but that must be correct. 1 plus R over M power M minus 1 minus 1. So we compute the effective interest rate for each option, and we start with the post office, MIS. Post office, MIS, where the nominal rate is what we call in RR, 8% per annum. M is 1. Here M is 1. Because if it's the interest rate is per annum, or it's monthly interest rate, monthly, they're saying post office MIS scheme monthly interest. So M is 12. M is 12. M represents the number of times interest is compounded in a year. The number of times interest is compounded in a year is what you're calling M. And in this case, they are compounding monthly. So M is 12. So then the effective interest rate is equals to 1 plus 0.08 over 12 power M 12 minus 1. So get the interest rate here. Get the effective interest rate. Then we will go to ICD bank deposit. Let's first write, then we will compute. Let's first have this, then we will compute. ICD bank deposit, they're saying quarterly interest. So our nominal rate is 8.25% per annum. M, the number of times compounding occurs in a year, it is quarterly, so 4. Then effective interest rate is equals to 1 plus 0.0825, you divide by 4, then power 4 minus 1 is equals to, and the last one is HDFC Limited. HDFC Limited. Here the nominal rate is 8.5% per annum and half yearly. So here compounding occurs semi-annually, so it must be 2 times in a year. Effective interest rate is equals to 1 plus 0.085 over 2 power 2 minus 1. So now let's compute now. Let's compute. Get me the answer for the first one. Kindly save time, save on time. I've said I want us to do away with this topic today. And we have a lot to cover. $8.29%. Okay, whatever answer you are getting, multiply by 100 to get it in percentage. So now the answers are too many here. So for this is 8 point. Oh, that's okay. That's okay. 8.29, 8.3 is okay. Otito, yours. Yours is for which one? Because yours is a bit different. ICD. Okay, 8.51. Let's have the answers in 2 decimal places. 8.51. 8.51. Then the other side, HDFC, 8.68. 8.68. 8.68. So I believe that is okay with everyone. A vote that is for 8.5, or that is for this one. Okay, fine. Okay, thank you, vote. That is it for that question. Unless someone has been left behind, we go to another question. Any question before we proceed? Oh yeah, we are supposed to advise. We are supposed to advise because the question says, using effective interest rate method, advise 𝐎𝐍𝐋𝐿 on the preferred investment option. The preferred investment option is the one that provides the highest effective interest rate. So which should be this one, HDFC Limited. So say the preferred investment option, advising the preferred investment option, is HDFC Limited, since it has the highest effective interest rate. Full stop. Then August 2023 question 5B. August 2023 question 5B. And I said, make sure you get the concept. Don't just compute, don't just write. Ensure you understand the question. And one thing, these financial management questions, if you want to get the concept and if you want to survive in financial management, number one, make sure you understand the question. Read the question and understand. Make sure that you can explain the story in that question, so that when you are doing the question, you're just converting whatever you've understood into writing. So like in this question, we're saying August 2023. Question 5B. August 2023 question 5B. That question reads, it's 5B. Joel Ouma needs shillings 5 million in 5 years' time to purchase a house. So this man wants to have 5 million shillings 5 years to come to purchase a house. Then he is determined to deposit a given amount of money each quarter in a sinking fund that earns interest at the rate of 12% compounded quarterly for 5 years. Required, compute the amount of money that Joel Ouma should deposit in each quarter in a sinking fund so as to enable him realize shillings 9 million in 5 years' time. And you can see that question is 5 marks. Very short, but 5 marks. Now, so let's start. Okay, this is now where understanding the question is coming in. You must understand what the question says, what it requires, so that you can know what to do. Now, in this case, you've been given the future value is 9 million. Say future value here. This is the money this person wants after 5 years. So then N is 5 years. Because they're saying 𝐎𝐿 needs shillings 9 million in 5 years' time to purchase a house. He is determined to deposit a given amount of money each quarter. So he is depositing each quarter. So the number of times he is depositing money in a year is 4. Because a year has 4 quarters. So he is depositing 4 times in a year. In a sinking fund that earns interest at the rate of 12%, the interest rate is 12%, but compounded quarterly, at an interest rate that's, so they're saying he is determined to deposit a given amount of money for each quarter in a sinking fund that earns interest at a rate of 12% compounded quarterly for 5 years. So now the question is, compute the amount of money that 𝐎𝐿 should deposit in each quarter in a sinking fund so as to enable him realize 9 million in 5 years' time. In 5 years' time. The amount of money that he should be depositing in each quarter in order to make it at 9 million after a period of 5 years. So here we have 2 methods. We can start by computing the effective interest rate. So, but before that, this is the future value. And we are looking for an annuity. We've just said that future value of annuity is equals to the annuity times 1 plus R power N minus 1 over R. That is what we've said. So the annuity, this is what we are looking for. Because the annuity is the amount of money that he will be depositing each quarter. Then the future value of the annuity is the 9 million. So here you can say 9 million. This is the 9 million will come here. This is what we are looking for. How much should he be depositing to make it 9 million after that period of time? We will start with the effective interest rate method. Effective interest rate method. Whereby we are supposed to adjust the interest rates to reflect quarterly. This interest rate here, this 12% we said, we are calling it the nominal interest rate. We said the nominal interest rate is given on annual basis. It is per annum. It is for 1 year, 1 financial year, or not just annual. It's an annual rate. So, but here, the compounding is done quarterly. That means you're supposed to adjust this interest rate of 12% per annum to reflect quarterly compounding. So here you can just say per annum. So we will start with this. Effective interest rate you're saying is 1 plus R over M power M minus 1. And I said, always in financial management, whenever you're doing a question, write the formulas. Write the formula. Even if you know it, just write the formula. It will even direct you on what to do. Like this one now, it will direct you. You will know this is 9 million. This is what I don't have. The rest I have. So here you'll say effective interest rate is 1 plus 0.12 over 4 power 4 minus 1. So get the effective interest rate. Get the effective interest rate. 12.55. 12.55%. Now this is what we are going to apply as our R. So we'll say future value. Oh, no, we are not repeating that again. We will say present value. Is it present value? No, future value is 9 million is equals to annuity. Annuity is what we don't know, times 1 plus 0.1255 power 5 minus 1 over 0.1255. So first get this factor. Get this factor in 4 decimal places. This factor should be in 4 decimal places. So annuity will be 9 million. You divide by the factor that you're getting here. Uh-huh, 6.4226. So please get me the amount here. Divide, you get me this amount. $140. This figure is too big, my friend. This is 1 million, eh? Someone else, kindly. Okay, fine. Let's see, something must be wrong somewhere. This one is for 5 years. Just a minute, we will see, we will compare. We will see where we are going wrong, if at all we are going wrong. We said we have 2 methods of this, eh? We said we have 2 methods of doing the multi-period. Remember, we called it multi-period compounding. Multi-period compounding. So just leave this the way it is. We will come back to this. I will check where the issue could be. Now we have this. We said number 1, you can adjust the number of periods. You adjust the number of periods, and again you adjust the discount rates, and then you do the compounding. So method number 2, this is number 2. Just say or say number of periods will be 5 times m 20 years. We will get 20 years there. Then discount rates. Discount rate, we said, sorry. This one should be, so I just wanted to say N times M, which is 5 times 4. You get 20 years. You get 20 years. Then discount rates will be R over 2, not 2, but M, R over M. So 12%, 12% divided by 4, we will get 3%. We will get 3%. So we are saying, instead of using the effective interest rate method, we have another option. We have another option of adjusting the number of periods, because you're saying, if this person is going to save for a period of 5 years, and each year is saving 4 times. So the number of periods will increase. So it's like saying we have a period here. This is 0, this is 1, this is 2, this is 3, this is 4, and this is 5. So these are 5 periods. 1, 2, 3, 4, 5. 5 years. But you're saying in each year is making 4 payments. So there are other periods here. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. 1, 2, 3. So these are not the period, because compounding is occurring quarterly. We are supposed to count this 1, 2, 3, 4, 5, 6, 7. They will be 20. Then the interest rate that we have is for 1 year, 12%. But we are only compounding for quarterly for 3 months. So you divide by 4, you get 3, 3, 3, 3, which must add up to 12. That's why we're saying R over M, we're getting 3%. So with that now, we can apply this formula. We can apply this formula. We say annuity, which is 9 million, annuity, which is 9 million, is equals to power 20 minus 1 over 0.03. So then now you say annuity is equals to 9 million over the factor that you'll get there. Let's have in 4 decimal places, Anna, in 4 decimal places. So you're getting 33. $334, $941. So this is 26. It said 26, 26.87, 26.8704, 8704, 26.8704. Then here the annuity, you're saying shillings, 334,941. 334,941.05. So that should be the correct answer. That should be the correct answer. So that means here, you're supposed to adjust the periods again here. This one, this effective interest rate, we adjust. We adjusted to, like we've adjusted there. So it is the same thing. So here the number of periods will change. So here we are supposed to say divide by, just a minute. You divide this by 4. So this will become 20. Then you divide by 0.1255. You divide by 4. So that is where the issue was. After getting the effective interest rate, you will still again adjust the number of periods. So get that. Just check now. Check now. Okay, it will not be the same, but almost the same. Rounded off. Check whether you're getting the same. Enad, are you getting the same answer? Hi, 330. 330 is a bit low. If you divide 12.55 over 4, then you use 20 here. The same case here. This is becoming almost the same, 3 point something, 27.39. Or 332.82.81. 338.82.81. So I would advise we go with this. This will not complicate issues. This will give us the exact figure, this method. Because here we've adjusted the number of periods, we have adjusted the discount rate, we are getting full numbers, or rather whole numbers. Then we apply the formula, we get this. So this is okay. Let's go with this. Let's go with this. This is more accurate. That is more accurate. That's more accurate. Now, do we need to do another one? Let me see. April 2020, April 2023, question 5D. Let me see whether it's April 2023. If it's similar to what we've done, we're just going to proceed. So they're saying John Osoro has deposited 7 million into a savings account at an annual interest rate of 5% compounded, with additional deposits of 10 per month made at the end of each month. So this is a bit different. I've advised we go with this, Martin. I've advised we go with this method of adjusting the number of periods and adjusting the discount rates. This one will not mislead you. So let's have April 2023 question 5D. April 2023 question 5D. Question 5D. April 2023 question 5D. Now, John Osoro, that question for John Osoro. That question for John Osoro is what you're looking at. The question says, John Osoro has deposited shilling 700,000 into a savings account at an annual interest rate of 5%, compounded monthly. So John Osoro has deposited 700,000 into a savings account at an annual interest rate of 5%, compounded monthly, with additional deposits of shillings 10,000 per month made at the end of each month. Required, determine the value of the investment after 10 years. Determine the value of the investment after 10 years. So here we have a lump sum. We have a lump sum of 700,000, and we have annuities of 10,000 per month. And this will be done for a period of 10 years. So you need to get the present value of each separately. So here we have a lump sum. We have a lump sum of 7 million. We are saying shillings 700,000, sorry. 700,000. So initially he deposits 700,000 shillings into a savings account at an interest rate of 5% compounded. This is per annum at an annual interest rate, 5% per annum, but compounded monthly. M is 12. M is 12. The number of times compounding is occurring in a year is 12. Then compounded monthly with additional deposits of shillings 10,000 per month. Annuity. There is an annuity here. Shillings 10,000 per month. 10,000 per month. So what I'm saying, how we are going to get the present value of this lump sum is different from how we are going to get the present value of this annuity figure. Because here the question says, determine the value of the investment after 10 years. So here is saying value of investment, is equals to present value of the lump sum, no, after 10 years. Determine the value of the investment after 10 years. So value of the investment is equals to future value of the lump sum, plus future value of the annuity, future value of the annuity. Now, we need to adjust this here. Let's start by adjusting the number of periods. Number of periods, we have said, number of periods is equals to n. Where is n here? We don't have n. N is 10 years. N is 10 years. Number of periods is n times m. So n, 10 times what? 12. We get 120. So the number of periods is 120. Then the discount rate or the interest rate, we can just also call it the interest rate. The interest rate is R over M. 5% divided by 12. 5% divided by 12 because compounding is occurring. Compounding is being done monthly. So get the interest rate, that is consistent with compounding period. Five over 12 is what? Five over 12. No, but this one, yeah, let's have it the way it is. 5, if you divide by 12, I'm getting 0.42. Let's say 0.42%. 0.242. Don't forget this is percent, because we are going to divide further by 100. We're going to divide further by 100. So we start with the future value of the lump sum. Future value of lump sum is equals to the lump sum, or let's say future value of a lump sum is equals to present value 1 plus R power n. So this one will be 700,000 is equals to, or rather times 1 plus our R is now the adjusted one, 0.42 over 100 power the periods 120 power 120. That will give us the present value of the lump sum. Then future value of the annuity. Future value of annuity. Future value of annuity is equals to the annuity times 1 plus R power n minus 1 over R. Again, for R and n, we are going to use the adjusted values. So our annuity is 10,000. 10,000 is what we are saving monthly. So times 1 plus 0.2 0.42 over 100 power 120 minus 1 over 0.42 over 100. So here we will get the future value of the annuity. So remember, the reason we are just dividing by 100 because we want to convert this percentage to numbers. We are converting the percentage to numbers. So basically, the 100 has no other reason to be there, because you can just say 0.0042 and you'll be good to go. So the first one I'm getting 1157,508. I don't know what you're getting. 1157,508. 1157,508. Confirm whether you're getting the same. 1157,508. Yeah, that's okay. Let's have the present value of the annuity now. So this one is 1 plus 0.0042. Close the brackets, power 120 minus 1 divide by 0.0042 times 10,000 times 10,000. I'm getting 1556 150. 1556 150.42. I believe you're getting the same. 1556 150.42 for the annuity, for the future value of the annuity. Then now you add value of investment. Value of investment is equals to 1157,508 plus 1556 150. Ignore the points. Ignore the points. So this is 2,713,658, 2.7, 271, 3959. Bernard, why is mine different from yours? Who is right, who is wrong? 1157,508 plus 2713,658. Okay, fine. Mine seems to be okay. So that is how you do time value of money questions. Like I've said, here there is no format. It is just getting the concept. For example, this question that we've just done, this April 2023 question, 5D. Do you think you can do all this without having the concept? Without knowing that one is a lump sum and there will be an annuity, and also knowing that how you get the future value of the annuity is different from what you get use, we get the future value of a lump sum. Plus again, adjusting the number of periods with the number of times compounding occurs in a year and adjusting the discount rate to reflect the number of times compounding occurs in a year. Here, it is just getting the concept, not a matter of cramming or what. So just keep on, we've very many questions on this in the past papers. Even in August 2025, there was a question. Last sitting, I don't know. So make sure you look at those questions. And in case you have a question, you will ask. Let's proceed. Let us look at something else because I want us to finish this today. Under that, right, loan amortization. Loan amortization schedule. Loan amortization schedule. Loan amortization schedule. Loan amortization schedule. Now, a loan amortization schedule, this is a schedule that is used to determine the amount of installment that one should pay when they have borrowed